Good day, ladies and gentlemen. My name is Venkat Pillai. I'm the founder and CEO of CloudFrame. Today, we're going to talk about COBOL to modernization, COBOL to maintainable Java modernization challenges, CloudFrame's innovation that expands what's possible. Today, we have hundreds of viewers in this, hundreds of listeners in this webinar, and that speak to the volume of interest that this webinar has generated. So we'll go through the motivation behind modernization, the challenges, how people have solved this problem or what they are doing to solve this problem. And then we'll talk about the innovations. If you take a look at the motivation, it's pretty clear. It's been there for a long time. The risk factor of what you're going to do with your legacy application, the application that was written 30, 40 years ago, the subject matter experts have moved, maybe retired. And even if you bring a new generation of people to start working on your legacy system, they don't know what was originally done because of the technical debt that got accumulated over the period of time. It's extremely hard. It's a risky to your business. The cost of the software licensing, the hardware, and everything else, it's adding up. It also inhibiting you to do innovation into your business, anything that you want to innovate. And if your applications got stuck on the legacy side of it, you have a boundary between your modern systems, the cloud native systems, and the system that's running on the mainframe. That's inhibiting your innovation. And of course, you have a competitive pressure. The fintech startups are coming up and eating lunch of all the financial companies. Same with the insurance company. The insurtech startups are coming up and threatening the business, the revenue, the profits, manufacturing, healthcare, airlines, wherever you talk about it, the mainframe, the competitive pressure is growing. So why haven't people tried it? Well, if it was easy, anybody would have done it. People have tried. They have tried since 1980s when people were worried about the rising cost of the maintenance of the mainframe, the software licensing cost. They were not successful. In 90s, when the cloud server came in, people really got excited. They thought, well, the mainframe is going to be dead. There were bold predictions like that. Didn't work out. It failed. Integration was a big problem. Y2K, people thought, oh, well, business is funding it. We have a budget for Y2K problem. Why not we also use that money to take this opportunity and move into the distributed side of it on the client server architecture? Did not work. And then in 2010s, and the mobile and the cloud started to ramp up the volume, and the volume started going up on the mainframe. People started thinking, how can we modernize? They tried big bang approach, they tried data first approach, data lake approach, Hadoop type of approach, all kind of approaches. Didn't really work out. And what's new now? We also have a new technology coming up. That a lot has changed. The hardware is better, the clouds are faster, and then we have an artificial intelligence coming up. So is anything going to change? Well, let's see. What have people done in the past to do the modernization? We heard about it. There were 3 R's for modernization. The Gartner has 5 R's. Some people have suggested 7 R's. If I talk to a lot of architects across the industry, people, I find it very difficult. It's too confusing. Rehosting, replatforming, refactoring, just make it simple. So I think of it as 3 simple things. A greenfield development where your architecture or your visionaries in the organization have decided that we're going to do a fresh development as if legacy system doesn't exist. We want to design a system the new way, the cloud native, scalable, agile, the latest and the greatest technology. Difficult thing to do, and we'll talk more about it. The brownfield development. Well, some people are saying, I'm going to be practical. We just have too much stuff on the mainframe. Things were done for last 30, 40 years. I'm not just going to take the whole thing, compress it in a timeline of 2 to 3 years, and redo everything as a greenfield development. Maybe I can leverage, take these things and move it off and run it on a different platform. Is it really giving you any benefit to your business? Call it a brownfield development. And there are some people who are kind of in between. We call it a blue field development, where they say, well, I do want to get out of mainframe at some point of time because of all the reasons we talked about. But let me do it this way. Let me see if I can leverage some of the things that was there in the legacy world, and then only focus on things that's going to make a big difference to my business and a lot more practical approach. So why have all this modernization project failed? First of all, we, the people in the IT, are extremely optimistic people. We think, yeah, we can do a greenfield development, 3 years, it's going to be fine. We can redo everything, rewrite everything. Well, go back and think about it. Something that was done for 30, 40 years, so many business requirements, regulatory requirements, compliance requirements, everything has gone into it over a long period of time. And all of a sudden, you want to take all these things, compress it in a small timeline, show your business that you will have a return on investment of all the money you're going to for the modernization and get it done. Overly optimistic, misunderstood the application complexity. In majority of the cases, that's the reason for the failure. Applications have codependency. Well, back in those days, the mainframes, the systems were not that powerful enough. 8-bit architecture, 16-bit architecture, there were a lot of dependency to everything. The hardware was not that sophisticated. So when people design their application, they try to squeeze every bit of performance they can get out of it. What it created a lot of technical debt, a very dependent application with each other. Everything is running together. They want to run fast and furious back in those days in the older hardware. But that's not the case today. But you take those applications, try to modernize it, you have a problem. And then, of course, there are infrastructure issues, So you have all sort of problem. People in the past have tried to move their data. For example, people had terabytes and terabytes of data in DB2, IMS, and other databases. They tried to move it to SQL Server or the distributed platform. Back in those days, even they tried, the hardware were not scalable enough, fast enough. Even today, I think there are struggles moving that amount of data all of a sudden into your infrastructure. You really got to design it right. That's one of the reasons why this modernization projects fail. And there are people who have really tried this big bang approach. They say, we have so much of dependency. It's going to be very difficult to just take like one small application, move it, and then another application and move it, and then create a backward compatibility and all those things. It's just too much. Let's move the whole thing off. So that means we have everything running on mainframe on Sunday, and Monday we're going to be in the new cloud system. That's a big failure. It doesn't happen. And then a bigger problem is the data issue. People have tried to move COBOL 4 to COBOL 5. They had problems. It was because of the data issues. Imagine you're just moving from one COBOL version to another COBOL version. And now you take this and explode your complexity nth level, where you're going to move your data, migrate your system, change everything, your infrastructure, your definition. It's too much to handle. So let me give you an example. I work with a company, just a small example. The social security number had junk data in it, but it works perfectly fine in COBOL system. Why? Because COBOL takes the lower half of the hexadecimal nibble, uses that as a number, as your display numeric number, works fine. The social security number is fine, data is fine, customer is happy. Move the system off mainframe, migrate your data, you got a junk data. This is just one field, one customer, and there are zillions of them all over the place, all kind of complexity. Distributed system, it's a junk data. Try to convert to social security number, doesn't work. Customer can't find its account, things won't work, system is broken. Can't afford it, especially for your mission critical application. The complexity is through the roof, and that's why your modernization project failed. So we talked about the 3 paradigms: the brownfield development, the greenfield development, and the blue. And you take a look at this graph. That's the decision curve. You got to think about it. On the bottom, your x-axis, you have a legacy functional equivalences, where you want to be in your system. And then on your y-axis, you have your design quality. The people who are on the greenfield development side of it, they say, the highest important to me is the design quality. I want domain-driven architecture, microservices, scalable, agile system that can scale infinitely horizontally in the cloud. They're gonna find it really difficult to match their functional equivalency. The things that worked on the mainframe and the calculations that were done, you take it away all the way to your greenfield development, won't match. Even I'll give you a simple example. You do a mortgage interest calculation, compound interest calculation. Take your calculator, do a calculation. Now you write a COBOL program and try to do it on the COBOL side of it. Depending on your scale, the decimal numbers, your compilation options, your results will not match with what's in a calculator. If you rewrite this application in Java, same results. This is just one simple example, and there are zillions of calculations that are going on there. And there are some calculations that are closed-end mutual funds, the performance indicators, your insurance compensations, all those calculations were done in the past. You cannot change them. Your business will not accept it if you redesign the system and your numbers are not matching. Right or wrong, if COBOL had done a wrong calculation, let it be wrong, but that's the way those calculations were presented in the performance numbers or graphs or reports to the customer. Customer cannot see a difference, should not see a difference. That's a big part of your challenge. So that's where the brownfield development seems like a really good approach for the people who says, I can't take a risk of my business having a wrong calculations or data. But are you really moving the needle? You want to move your design quality. You want to have a high design quality. So somewhere in between is your blue field development, where you can take a few systems that really going to make a difference. Take the system that are high cost, high operational cost, low benefit to your business, maybe just do a brownfield development. So it's a combination of the greenfield and the brownfield. Where comes the middle ground is your blue field development. And CloudFrame gives you an opportunity to go anywhere you want it in this curve. And that's the big part of it. The lever it gives you a lot of freedom of your generated code to move the lever or the slider where you want it to be. Let's also take a look at quick challenges you have moving from COBOL to Java. We talked about moving from COBOL 4 to COBOL 5, how difficult it was. That COBOL 5 is nobody wants to do it anymore. IBM said, you guys want to move to COBOL 6, skip 5, because 5 had so much of problem because of the backward compatibility and data challenges and all those things. It's not there anymore. Now you're going to take that COBOL program and move it to Java or newer languages. There's going to be huge differences. You have design differences. Your COBOL, you know that it's monolithic, procedural, has callable interface, error handling, exception handlings are different. Naming conventions are different. Your data set names, some of the names are 8 characters, 30 characters. There are limitations. And you're going to move this to the new system. How are you going to do it? Structural differences. All these COBOL programs or legacy programs were memory-based. All the data manipulation was done memory-based. The modern programming language don't work that way. The data type differences. COBOL has enormous number of data types, comp1, comp2, comp3, display numeric, all kind of data types. Makes it really hard for someone to do all the conversion, figure out what they are. So imagine you try to understand the logic out of a system where a system can have a display numeric number, can act as a string and a number at the same time. And then there are things that are done if it's a string versus there are things that are done when it's a number. And all those complex logic, your head is going to go spin and try to do a greenfield development out of it. Very, very hard proposition. And then, of course, there are logical differences. That is the biggest problem. We talked about calculation differences. There are conditional differences. In COBOL, your character have length. They're bounded. You try to compare a character string of length 10 to a character string of length 30, you might get a different calculation. You can't, in the Java, you just have a string dot equals or something like that. It's not the same evaluation. Your conditional evaluation itself could cause a problem in your logic and can take you to a different path. And then on top of it, you have code page differences. A character on the mainframe is abscisic based. You compare two characters, a greater than, less than, is going to be different when you move it to a Unicode system. So when you do your data migration, you do your sorting, sort order will be different. And those are the bigger challenges than anything else you have to handle as part of this. So the people who are tackling the challenges with the Greenfield development, they're saying, well, there is too much debt in the legacy system, too much interdependency. I think best way to do, I talked to one architect, really senior guy. He said, when you have so much of technical debt, blow the whole thing, redesign from the scratch. That's the best way to do it. You have this old house it's impossible to make changes. How about I destroy the house and rebuild it and build the beautiful architecture that we wanted? Looks great on the paper. Looks fantastic. But when you start looking at the budget and the timeline and the ROIs, and while your business is, pushing you more agility and more changes, that's where you figure out the practical problem to this approach. There are structural differences. Doesn't really matter because you're redesigning the whole thing. It's not going to be the way it was in the legacy system. Logical difference is where you're going to find the biggest challenge. You talked about blowing away the whole legacy system and redoing it. Be prepared to blow away your timeline and return on investment. It's going to cost you a lot more money, a lot more time. People are very optimistic, like I said. When they start looking at the system that was done 30, 40 years ago, when you get into the devil is in the detail, you're going to figure it out. It's an extremely difficult problem. And where I see people get stuck is the business certification. The business looks at it and says, I'm not sure. I have to validate everything because things are not matching. Corporate action, stock calculations, insurance calculations, whatever it is, your business is going to go back and have to certify everything. Be ready to spend huge amount of time in testing. That's the problem and challenges with the Greenfield development. On paper, looks great. Fantastic idea. Reality, very different. The Brownfield development. People have tried that for a long time. They're not happy. You go, more and more people I talk to, they say, we don't want a system that you just lift and shift. We want some value add to it. We want to make it easier. There has to be some value proposition. You're going to take your procedural system, convert it. The best you can do, maybe make it partially object-oriented. Structural differences, some of the structural differences are going to be really hard to take it away in a brownfield development. So majority of the time, people create frameworks. Just watch out for the proprietary framework, because if you convert the system through automation or through whatever means, and you're stuck with a proprietary system, you haven't really moved the needle anywhere. You've got to make sure the system that you move is an open source or open. You can make changes for the future. You don't want to go back to COBOL and redo these things. You really want to go back and maintain as a Java. And that too, it should be maintained by the person who has no mainframe knowledge. Can he or she do it? That's what you got to watch out for here. And the logical difference, that's always gonna remain the biggest challenge. And even if you're able to maintain the logical differences and you give the exact calculation, watch out for the maintainability. And that's where CloudFrame can make a lot of differences, whether you go with a brownfield development or the greenfield development. You can move the levers. We make sure that when you do a brownfield development, your functional results are exactly matching. So when you go to your business, they're not going to find any difference. So that's where the CloudFrame comes into picture. We make sure that we have aspect-oriented programmings. We also provide a human provision for reinforcement and feedback if you want to, on top of the generated code. What it does, it takes you closer and closer to the greenfield development by a subject matter coming in and giving feedback on your generated code, and you can rearrange your code and restructure your generated code. Structural differences, we use Spring Boot, Spring Batch, and logical differences, we guarantee that we give you the lever. If you want 100% functional equivalence, we make sure that your results are going to be exactly the way they were calculated. Yet, we give you the maintainability for a Java programmer without knowing the mainframe constructs or mainframe fundamentals. So as an example, we'll go through a few code examples of what we do. We generate the classes. We throw away all the COBOL complexity. comp1, comp2, comp3, comp4, comp5, a Java person or the person who's on the distributed side will not know the differences. A display numeric value versus what are the zone decimal, edited numeric, and things like that. Really what they care about the primitive types. Java type is simple, short, int, long, maybe double, maybe mad.big decimal for more precision, because big decimal and the rounding can give you the same calculation that you had on the mainframe. And how the rounding should be done is all taken care for you and generated correctly. Maintainability is simple. People know Lombok. The documentations are available. Want to make a changes, make a change, simple change. Sometime, if you take a COBOL program and you take a decision to just take your COBOL paragraph and convert it to a method, if you decide to do that, you're going to realize that those paragraphs don't have inputs and output. Every variable in COBOL is a global variable. What CloudFrame will do is, first of all, it will try to figure out the right method for the right work, reduce the complexity. And in some cases, if it cannot do it, to at least make sure the methods have a very clear, defined inputs and output. So if you're a Java programmer, you're running in your IDE, you do control space, you're going to get the proper getter and setter. So you can see every variable that are coming in and modified in the methods. It makes it easy for you to do future modification. We generate the code in a layered architecture. That's a very important part of the code generation. You take your COBOL program, a monolithic program. Sometime I have seen program 300,000 lines of code, 400,000 lines of code, one single program. You look at it and your head goes spin. It's being done over the period of 30, 40 years. People didn't know what the previous person has done. They don't want to take a risk. They don't delete the code. They add a new code. There might be dead code. We go through, you feed in hundreds and thousands of programs to CloudFrame. CloudFrame will do analysis, try to figure out where is your business logic, where is your service, where it could be a controller level, the repositories, split things apart into proper layers. It makes it easy for you in the future. If you want to add your own logic, you have a proper layers where you can feed things. And the layer architecture, the clear separation of layers will make super easy for you to do the maintenance. And exception handling, it's a big part of it. COBOL especially is based on our mainframe, is based on the return code or status code based error handling. You call an MQ, you're going to get a return code or a status code. You open a file, you get a file status code. File status code of VSAM, file status code of 96 may mean something. A file status code of 5 or 35 may mean something. SQL code -805, -904, whatever, -811 may mean something to you. Now, when we generate the code, we split things into the layer. We also make sure that we can take your COBOL generated code convert into Java and convert into proper exception handling. Like, for example, you will get application exception, SQL exception, file not find exception, things like that, which makes sense to a Java programmer, not just a return code or a file status. That's going to be hard for you to maintain. And that's big part of the code generator. Then on top of it, what we do is also allow you to bring in a subject matter expert and provide you a GUI where you can shuffle things around. You can clearly define your domains and bounded context, reorganize things, shuffle things around, rename, republish. When you publish it, it's going to reshuffle the whole code and put it in the right layer, right architecture, right components, right jars, common module, split things apart, and give you a structure, a Maven or a Gradle package that will be a lot easier for you to start working on. So it's going towards blue field development rather than a brown field development, where things are moving more towards a greenfield development. You can't have 100% greenfield development, or you can if you decide to move the lever on the CloudFrame code generator. It can still help you, but you will have to figure out where is the right balance for you. So where things are going from here. So let's talk about transformer. And I use the word transformer interchangeably. So for example, in the past, people have done a code generator, a code converters. What they really are, I would call it as a deterministic transformer. And the reason I'm using the word transformer is because I want to introduce the artificial intelligence and the things that are going on in today's world and how they're going to change the future. The deterministic transformers are pretty simple. They are rule-based, they are code-based, they are conditions that are well-defined. You feed them something, a legacy system, what you get out is very predictable, very traceable. If you want to figure out how did this happen, you can always trace it back. And you want that, especially you want to make sure the system that are critical, mission critical, you want to have a very well-defined output. You know how to debug it, how to trace it back. Versus the probabilistic transformer. And that's where the machine learning and AI come into picture. They are neural networks, they are complete black box. The weights can do anything depending on what they have learned, what they have seen, depending on the temperature and the other parameter that you feed it in. Outputs are completely untraceable. And why that happens? I think where AIs are really struggling is, like I talked to a lot of architects, I also talk to a lot of researchers. I look at the AI research papers that are published in Arwix and other places. You have IBM working on a project CodeNet. You have Meta, the Facebook guys are working on transcoder. They can do okay job converting from Java to C# or C++ to Java, an object-oriented language to object-oriented language. Still, they are not ready. They are 60% accurate, sometimes 80% accurate. The reason for that is attention. And there was a beautiful paper published some time back by one of the AI researchers. Attention is all you need. It works great on a natural language processing. You convert from one language to another. You look at ChatGPT or GPT 3.5 or GPT-4 model. They are generative transformers. They work fantastic because they have 175 billion parameter, 96 transformers and things like that, that can provide a proper attention to previous words or sentences. For example, in your sentence, you have two nouns and two pronouns. You don't know which pronoun will have attention to which noun. If the human can intuitively figure that out. And AI is now able to figure it out. But when it comes to the code generator, not yet. There's a lack of attention. The things, a working storage variables defined somewhere can have an effect on the program, or some changes were done in the previous call statement in a different program can have an impact on the program downstream. The attention span is not there. AI has not solved this problem. And that's the big issue with artificial intelligence today. Where CloudFrame is going, and that is where it's going to be game changer. We do deterministic transformer, and that's pretty useful for your blue field transformation. We are moving, also adding a probabilistic transformer. And the probabilistic transformer, why is it going to be different? So you take a look at the GPT, which is generative pre-trained. We also allow an ability to post-train. That means it can be customized to your environment. But where the difference is going to be the special attention, the way we're going to do it. It's coming out soon, so watch out for it. We feel it's going to be a game changer. So let's take a look at what innovations that we expand and what's beyond what's possible. So what we generate is a DevOps ready, readable, understandable code, eliminate code bloats, dead code, clear method generations, best practices, component management, has a consistency, traceable, create a layered architecture. You have Spring Boot, aspect-oriented programming, dependency injection. And where we are going is more towards much more powerful transformation, better pattern recognition. The AI emphasis is going to be a big deal. And putting the balance between a deterministic and probabilistic is where we excel. So to go back to the same chart, the decision curves, pretty important for anybody who's doing the legacy modernization. Brownfield versus greenfield. I think you got to be somewhere in the middle. You got to be practical. Or even if you do, brownfield, you got to watch out for a few things. Make sure you still have some value out of that brownfield development. You still should be able to maintain it. Yeah, you can squint your eyes and say, yeah, this Java looks funny, but can I maintain it? can someone with no mainframe knowledge work on it versus a pure greenfield development? Can I push some more things that I develop outside, some small piece of business logic that's very critical to us for agility and scalability? Can I inject into my brownfield development? That's where your bluefield development comes into the picture. So David, hand it back to you.
Yeah, that's great. Great information, Venkat. I appreciate you taking us through that. I do want to circle back to a couple of things that you mentioned, just to make sure that we've got a further explanation around them. You talked about pattern recognition as being important of one of the innovations that we're looking at. Can you explain a little bit more, or maybe give an example? I think sometimes you've used error handling as a pattern that might be something that's significant enough to explain what we mean by pattern recognition and how that's going to play an important part of what we bring to the table.
Oh, great question, David. Thank you. If you remember what I talked about, attention is all you need. And it was a great research paper, by the way. I encourage everybody to take a look at it. You might find if you just search for attention is all you need. That's how AI is working. But more importantly, that's how human intelligence works. We look at the code and we intuitively figure it out that it's an error handling. How we say, oh, if response code equals DFH resp normal, must be a CICS type program. So we are paying attention to few things and ignoring anything that we don't want it. You look at a COBOL code, and a human would intuitively go back and say, oh, this is an ETL type program. It opens a cursor or reads a driver file and does some processing and then finally writes it. What we have done is we have thrown away everything that we don't need attention to. We paid attention to what we really needed. And that's a pattern. But then we also have to pay attention to the detail once you have recognized a pattern. So what's important is for a really good code generator to give you a modern design, cloud native architecture, and something that's agile and really want to go, is figuring out what those patterns are. And that requires a deep domain expertise. Someone with a domain expertise can either define those rules in a deterministic transformer or train the AI in a probabilistic transformer, pre or post, something that we can pre-train it on the CloudFrame side and something that you can post-train it on your side. And those patterns, once they are recognized, it's a lot easier to get a quality design and quality code output. That's an integral and important part of code generator. And that is what people have been missing in the past.
Great. Good explanation. And thanks for clearing that up for me, Venkat. On the FAQs here, some of these have been gathered from other discussions that we've had. I think the critical design, critical decision factor chart that you pulled up a while ago talked about functional equivalency and domain-driven design. Can you give us a little bit of a background on functional equivalency and why, how we might define that a little bit better, just to make sure that we've got a firm understanding of what we mean when we talk about functional and data equivalency, for instance?
Sure. Yeah, we have customers who have tried everything. They have tried off-the-shelf product. They have tried rewriting the whole thing greenfield. They have tried brownfield. They were not happy with either one until they saw the CloudFrame generated code. So greenfield, obviously, they were happy with the design quality, but then they were not moving fast enough. And the business requirements were changing so fast that they couldn't catch up. When it comes to off-the-shelf product, there are certain business value they have put in the last 30, 40 years, and that differentiates their business, especially in the commodity markets. And if you bring an off-the-shelf product, what is the differentiator for them? But even if you put an off-the-shelf product, when they went through is they thought they're going to get everything right with all the customization that off-the-shelf product provided. But things were a lot harder. They had to wait almost 2 years, and they're still not done to validate the results and get it business certified. The validating result is a big part of it because you change everything. You change your data, off-the-shelf product, your schema, your logic, and everything. You have to go through every season and make sure that every season is okay whether it's a Black Friday season, whether it's a tax season, whether it's a month end, whether it's a year end, every one of them. A small differences. You never know when they're going to show up. There are things that are in the legacy system deeply hidden. The decision was taken a long time ago. The business requirements, documents are not there. And sometimes even the code base, the source code is not available. So the people who are working, they're completely working blind. Only way for them to validate the result is actually do a production parallel run. And that production parallel run is going on for last 2 years. Still not completed. They're still not satisfied. They're worried to switch the system completely. So that is where the functional equivalency becomes important, especially for the data that's legacy. It's coming from the legacy system. And where the customer has already seen the results in the past, business will not allow you to change the results. Maybe in the future, new system, new design, no problem. But the things that were already done in the past had to be maintained that way. Now, domain-driven design is actually a pretty important thing. Nowadays, everybody is thinking in those directions. It's a lot easier to split your domains, you have a bounded context, design your system appropriately, makes it easy for you to do a future development, to add functionality, add changes, the flexibility. Your legacy system were nothing like that. They may have been done with a great architecture in the past. It's not the same architecture. You can use it in the future. So having a subject matter expert say and design your system, whether you do a Bluefield development or Greenfield development, it's quite essential to you.
Mm-hmm. Thanks for taking us through that. I think I have a much better understanding of how we're describing functional equivalency. We do have a couple of questions that are coming into the Q&A window, and I want to see if we can address a couple of these. We have one question around interactions between COBOL systems themselves. Specifically, the example says through CTG or MQ, and how are we handling that? Do we determine if a REST API or a messaging API is best for that implementation? That's getting into actually how we're transforming the code. I don't know if we want to get down to that level of detail, but I'll tell you that's the question. And I'm not sure how you want to answer that, Venkat. So we'll just pause and let you maybe think about that for a second.
I think that's a classic example of a brownfield development. So you have a system which is quite tightly integrated, or things were done differently. You have a CTG coming up. CTG might insert data into a container, and then your COBOL program simply gets the container. For example, in CICS, I just gave a CICS example. You feed that program to CloudFrame, you're only going to feed a CloudFrame CICS program. It has half the picture. It doesn't know how the data came in. And you want to take that system, take the generated code, and try to figure out what you want to do. It's going to be harder. I think that's where the Bluefield development comes into picture. You have to have a subject matter expert. If you can find it, if you can't find it, it's going to be hard, but it's still, one option is take all your system, go through the brown field development. The generated code will be reasonable enough. It's understandable enough, maintainable enough. You can at least see what the system is doing. You can put it in your debugger because you may not have a subject matter expert. It's a lot easier for you to debug it through on a Java side of it than to debug on a COBOL side of it. Maybe on COBOL you have Expediter, maybe you don't have, maybe you still want to put displays. It's still debugging on the Java or the distributed side is going to be a lot easier for you. Mm-hmm. Understanding your existing system. And also, even in the brownfield development, CloudFrame will generate you very helpful comments that will be quite convenient for you or easy for you to go through. So take the system in case of this MQ and CTG or anything that are coming like that. One option is you want to do a Bluefield development. We will generate you the layers for you, the controller layers. You can go back and inject your own controllers, replace the one that are generated. We took you 80% or 70% or 80%, and you can do the rest of the 20%. It's still a big deal. It will still speed up your development.
Right. That's a good point, because accelerating, trying to get to value, what we call speed to value, is one of the important parts of using an automated tool to do the transformation. Is you get consistency you get the ability to reference, what's been generated there in order to replicate that going forward. So it does quickly accelerate the progress that you'll make on those rewrites. So that's a good point. We have a couple of questions that are here around. One was around prerequisites on the COBOL side, versions, quality standards, etc. And then I assume this is an anonymous questioner, which is kind of have a negative side to it because I can't follow up and send you answers. But I think maybe the same person asked around whether it's just for mainframe or whether we're involved in AS400 I-Series type things as well. So two questions there, one around prerequisites for COBOL, the other one around non-mainframe COBOL applications.
I think they are related answers. The question may not be related, but the answers are. We talked about a brownfield development, which means that we give you, CloudFrame will give you 100% functional equivalency. And that puts a restriction on a mainframe only. So that means any COBOL you have a mainframe, on mainframe, whether it's a VS COBOL, Enterprise COBOL, COBOL 4, COBOL 5, COBOL 6, whatever it is, you can use CloudFrame for that. Will it work on AS400? We don't have a functional equivalency for AS400 yet. Although, if you want to go somewhere beyond that and say, yeah, let CloudFrame generate the code and I want to see and maintain it from here onwards, I don't care about running the system as in the brownfield development, it's doable, but it's not something we are promoting right now. It's probably we'll put more emphasis later somewhere down the line. But right now, let's assume it's all mainframe.
Okay. And then we have a question that actually a couple of questions from the same participant. One was around some examples of CICS DB2 COBOL applications that have been transformed using CloudFrame. And then a more specific question from the same person was around transactional applications and how does the transformed application, meaning the Java application generated or transformed from the COBOL by our automated tool, handle the interaction with resource managers. So let me read that question again. For transactional applications, how does the transformed application handle the interaction with resource managers?
I'm assuming the resource manager means you're talking about the RRSAF facility, the two-phase commit or a multi-phase commit. So today, if you take your application in COBOL and you are using one of the resource facility provided by the mainframe, you're using probably RRSAF or one of those commit managers where you can commit across MQ, commit across DB2 if you're running in batch. If you're running a CICS, you have CICS resources, you have DB2 resources, you have MQ resources. CICS is providing a fantastic multi-phase commit to you. Moving into the new world, that is going to be challenged. You're going to replace your CICS. It's going to become probably a REST services call. You're going to have a controllers that might be running in one of those servers, maybe Tomcat or any other server that you're going to run it. Or and on the DB2 side, you're going to use JDBC. Maybe you want to change your data source, maybe start with DB2. On the distributed side, it's an easier one. MQ, maybe you want to replace MQ with either the distributed side of the MQ or maybe replace it with Kafka or something else. Two phases commit is going to be challenging. And that is why I talked about, do you want a brownfield development or do you want a greenfield development? If you were to do a greenfield development, what you would do is you're most likely going to have a microservices. You're going to handle the problem of consistency across the data or just acceptable consistency across the data differently in your design architecture. Then you would take a legacy application as in brownfield development and try to run it in a distributed platform. If you do that to the brownfield, you have to have a compensation mechanism where if something goes wrong, how do I compensate for the two-phase commit? So there is a little bit of work required in some cases, especially in case of two-phase commit.
Thanks, Venkat. Thanks for answering that. I want to close this off here. I've got one more question that may have popped in. Let me take a look at it real quick. It's around performance, I think. And the question says, compared to Java generated code and its legacy original COBOL program running on the ZOS mainframe, Will the Java code use less CPU cycles and perform faster? Will it be zip eligible? I think that's kind of a, we get into a couple of different areas there when we start talking about zip eligibility and what can run there. But let's go back to a second on the performance piece around using less cycles and perform better, because it's related to another question that we had around performance, which was whether or not there's an estimate that we use around performance, be that wall clock time or CPU cycles, that type of thing, of comparing Java that we've transformed from the COBOL. I can prerequisite that, wouldn't say it depends. I know that answer is going to probably come, but Venkat, I'll open that up to you and maybe have you talk about our experiences with performance and trying to get the best performance that we can out of the Java applications that we develop.
So I think that is where I need to differentiate the two product CloudFrame has. Product one, which is Relocate, the product that's purely meant to run on ZOS or completely backward compatible. That's where Java becomes zip eligible on the ZOS and uses the zip engine. Performance is pretty important factor because you may not have converted all your application. You may just do a piecemeal. Some may be Java, some may be running the assembler, some may be using MQ. And you talked about two-phase commit. This is a perfect example. Two-phase commit going to work great here. But that's not what this webinar was. This webinar was mainly for the different product called Renovate, where people are saying, I'm going to redo my system. I'm going to take the code from a legacy, either run it as a brownfield application, convert it to Java and run it, how the performance is going to be. Or maybe I'm just going to take this application, convert it to Java, see what the application does, debug it, and then maybe rewrite a pieces of it and restructure it the way I want it. Human feedback or human changes on top of generated code. That's what the second product is. And this webinar was mainly for that. The performance, again, depends on your design decisions you have taken. The Java works great. Today's machines are great, powerful machines. You feed it in more memory, more machines, more horizontal scalability. It's not a problem.
Okay. We've exhausted our time here in this great conversation. I want to make sure that we have a time to close off here. I do have the questions. If I didn't get a chance to answer those directly, or Venkat didn't get to answer those questions directly, I'll follow up with you. There are a couple of people that have submitted multiple questions. Venkat, if you could pop us to the next screen, please.
Sure.
One of the things that came up during the course of the Q&As here,
sorry.
back to one more back, was some ability to gauge and estimate what the deployment and cost would be for moving from a mainframe workload over to a cloud workload. We are working on a tool that we call CloudFrame Discover that does just that. Looks at your mainframe, looks at what's deployed there, the size of the mainframe, the applications, and then using Microsoft Azure supplied information, we're able to estimate what that deployment might look like in Azure. So we get the SKUs, we get the components that are necessary, and we can even calculate the pricing for that. So this is a new tool that we're running out. If you're interested in something like that or want to talk about that, please contact me directly. I'll have some follow-up emails that will come to you. If you'll reach out to me directly, we'll set up a conversation about that. We're obviously looking to introduce that product into the hands of some people that would like to get that information. So if you're questioning a mainframe workload and moving that to Azure and want to know what size that might look like and how much that might cost, this is a tool that will help you get there. So reach out to me directly on that. From a follow-up to this webinar, Venkat, if you'll take us forward here, the QR code that's on the screen here will take you to one of our intake people that will help you get scheduled to have a consultation with CloudFrame around your particular environment, what your challenges are with facing your COBOL to Java challenges. And we'd love to have that conversation and take a look at what you are planning and what your vision is for application modernization and see if there's something that we might be able to help you with. We have a number of different tools that help us kind of understand, what your challenges are with the existing code base, but we can also demonstrate what that transformation looks like, doing something called a proof of technology, where we actually take a couple of samples of your COBOL code and generate Java from that so that you can visually inspect it. You can take a look at what that's going to look like once we run it through the transformation engine, have some discussions around, what is configurable there, what is something that we can inject after the fact. So we welcome that opportunity. If you'll scan the QR code, I think you'll go to a scheduling app. We'll get you set up. We'll get a conversation going, and we'll get on the phone or online, not on the phone. We'll get online and figure out the best time for our team and your team to connect to answer those questions. So that's it. So I want to thank everyone that joined us today. We had a great group, great crowd. Loved the questions and the interaction. Venkat, I really do appreciate you taking us through, the innovations that CloudFrame's working on to make this maintainable Java question that we've always addressed. No one likes COBOL, but we want to get to a situation where DevOps developers can pick up the transform code, read it, understand it, maintain it, and take it forward into their environments for the applications that they're building. So I really appreciate you doing that, Venkat. Thank you, everyone that joined us. Good day to you, Venkat. So you can take us.
Thank you very much. Totally appreciate it.
All right. And I'll follow with you directly. Look for your inbox. We will see a notification that the recording of the webinar is available. Thank you very much. Have a great day.